All right, you guys. Looks like this might be interesting. We're looking at representing transformations in a plane. This is dilations. Well, the thing about a dilation is that it increases in size or decreases in size. I'm on slide 19 or page 19. So we're going to make something get bigger or smaller, shrink, enlargement, or shrink. So let's see what's going on. Click on my GeoGebra. Oh, okay. So I got a triangle here, and I got a slide. Now I'd imagine it just gets bigger and smaller. Okay. All right. So let's see here what's going on. All right. So move the slider to change the value of n. N, by the way, is what's called a scale factor. It's how much something increases in size or shrinks in size. All right, watch what happens to the pre-image and the image of the triangle. Again, pre-image is the original, image is the new. Set n to any value that you wish and enter it into the table. Then enter the coordinates of the vertices, A prime, B prime, C prime. Again, your primes are the manipulated one. That's going to be your image. Do this for at least 3 different values of n. Okay, so I'll tell you what. Let's make n 2. So I'm going to make it to double the size. Right now it's at 1, which is sitting on top of itself. I'm going to change it to 2, which means I'm getting double the size. All right, so it looks like my A prime is 2, 2. My B prime is 6, 4. And my C prime is 8, 2. So it went from 1, 1 to 2, 2. It went from 3, 2 to 6, 4. And it goes from 4, 1 to 8, 2. So if you'll notice, when your scale factor is 2, everything doubles in size. 1 times 2 is 2. 1 times 2 is 2. 3 times 2 is 6. 2 times 2 is 4. 4 times 2 is 8, and 1 times 2 is 2. All right, so we're going to put those values into the chart. All right, so that'll be 2, 2, because it's double the size. That'll be 6, 4, because it's double the size. And then 8, 2, because it's double the size. All right, how about we triple the size? Let's make our scale factor 3. So triple the size. All right, well, that means I'm multiplying everything by 3 now. So there's my original, and 1 times 3 is 3. 1 times 3 is 3. 3 times 3 is 9. 2 times 3 is 6. 4 times 3 is 12, and 1 times 3 is 3. So everything's going to be triple the size. Multiply everything by 3. So this will be 3, 3. This will be 9, 6. And then 12, 3. Okay, so how about let's make everything quadruple the size. We're going to multiply everything by 4. So for you visual people, there's the figure 4 times the size. We're going to have 4, 4, 12, 8, and 16, 4. Again, you're just multiplying by 4, everybody. 4, 4. That would be 12, 8. And this will be 16, 4. All right, submitted. Okay, I only gave us 1, but we get all 3. All right, question 2. What's the relationship between the coordinates of the vertices triangle ABC and the coordinates of the vertices triangle A prime, B prime, C prime? All right, so explain in terms of, well, so let's see. K is what you multiply by to multiply the original, the pre-image triangle ABC in order to get the new or the image triangle A prime, B prime, C prime. So when you have triangle ABC, multiply the coordinates by the n to get triangle, A prime, B prime, C prime. All right, so let's change the value of n some more and observe the lengths of the sides of the image change. Once you've settled on a value of n recorded in the table, measure the lengths of the sides A prime, B prime, C prime. Do this for at least 3 values. Okay, so all right, well, let's go with something easy. Why not? Why do something funky? So I'm going to make n2, which means my scale factor is 2. So again, I'm multiplying everything by 2. So I'm going to pull up my calculator. I'm going to multiply 2 times 1.41. 2 times 1.41. So it's 2.82. All right, so multiply 2 times 3. Well, that's easy. That's 6. And multiply 2 times 2.24. 2 times 2.24. All right, 4.48. Again, I'm going to make this easy. I'm going to make it a scale factor of 3, so I'm multiplying everything by 3. So 3 times 1.41. 3 times 1.41. 4.23. 3 times 3 is 9. And 3 times 2.24. 3 times 2.24. 6.72. All right, multiply everything by 4. So 4 times 1.41 times 1.41. All right, 5.64. 3 times 4 is 12. And then 4 times 2.24. It looks like it's 8.96. Easy enough. All right, again, just scale factor is what you multiply by. All right, based on the observation of question 1 to 3, what's the significance of a dilation when it's between 0 and 1? And what's the significance when n is 1? What about when n is greater than 1? Explain in terms of the size. Okay, well, let's do them one at a time. When it's in between 0 and 1, size image of the pre-image. All right, so if n equals 1, let me do this one first. The image doesn't change from the pre-image. It's going to be the same. It's going to just lay on top of itself. All right, so how about when n is greater than 1? When n is greater than 1, the image enlarges. In other words, it gets bigger. Okay. If n is between them, it's still going to get larger. So, because if it's a fraction, oh no, the fraction will get smaller. So if it's a fraction, it'll get smaller. If n is a fraction, the image shrinks. That means it gets smaller. Okay. All right, now take a look at the angle measurements. Okay, angle measurements. I'll tell you right now, angle measurements aren't going to change. They're going to stay the same. So now look at the angle measurements from the pre-image ABC to the new image ABC. Move the slider and observe the values of the angle measurements from the image and pre-image. Well, I'll tell you right now, angle measures aren't going to change. But let me show you guys, you visual people. I'm going to click on angle. I'm going to find all these little angles here. So angle A. You remember, when you're finding angles, you got to go in a clockwise motion. There's B. I want to move these so you guys can see them. And there's C. So let me click move. So angle A, angle B, angle C. All right. So let's do something easy. How about twice the size? You can't really see it very well, but I'm going to find the angle measures. So angle A is going to stay 26.57. And I can't see it, so I'm going to move it. 26.57. Boom. All right, so let's find angle B, which should be 108.43. Yeah, 108.43, and then C should be 45. So C should be 45. Let me move that so you guys can see it. You visual people want to see it. There you go. Angle measures don't change. I don't care how big or how small it gets. The only thing that changes are the ratios of the sides. Angle measures stay the same. All right, so, okay, I said n was 2. So let's see. Angle B was 108 because that's the letter in the middle. Angle B prime was also 108. All right, angle C. C was 45, so C prime will be 45. A was that 27? So A was 27. I'm just rounding here if you're wondering. It says to the nearest degree. All right, so you guys kind of get the idea. Let's do one that's less than 1. So I'm going to put my scale factor to a half. Can't see it, but I'm telling you now, they're the same. There's my 26. There's my 108. There's my 45. They are going to stay the same. So I went to a scale factor of 0.5, which is the same thing as 1/2. So 1/2. Angles didn't change, y'all, and they're not going to. They're on a dilation. So 45, 45, 27, 27. They're the same. Okay, so what can you conclude about the dilations from your observations of question 5? The measure of the angle measures aren't going to change each other. Sorry, I'm not in the middle of the video. Give me just a second. Let me type this in. The measures of the angles are not going to change, you guys. All right, so is that the last one? Oh, give me a second, you guys. I'm a